Good afternoon, everyone. Super excited you're all here. Hope you're enjoying your Universe experience so far. I'm Natalie Bradley. I'm a field architect with GitHub. I work with our customers to help them modernize their software development practices, most specifically at scale. Our customers, like many enterprise customers, are focusing on implementing DevOps practices, scaling agile methodologies, and shifting their culture to be more collaborative and transparent. And I think it's obvious why they're looking to do this, right? Because all of those practices and changes really enhance how a business is able to build at speed, deliver efficiencies, and quality products. But with speed, they often kind of find more security risks, shall we say, in your development process. So organizations are kind of trading off, do we continue to build at speed, or do we build more secure products? So with me today, I have a panel of experts on all things security and software development to kind of talk through this problem of how we balance both agility and security. So I'm going to turn it over to you guys to introduce yourselves, who you are, kind of what you do, where you came from, and your background, and a little bit about what software development practices look like in your organization. Rhys, can we start with you?
Hi. Wow.
Yeah.
So my name is Rhys Arkins, and I work at a company called Whitesource. I'm product director responsible for developer solutions. We are actually both a GitHub customer. We use GitHub very heavily to develop all of our software, but we're also a security partner for GitHub, where we build open source security solutions that integrate with GitHub and GitHub Enterprise. So we come from both angles there. And within Whitesource, we have a mix of both open source as well as internal repositories, and we have an agile methodology where we attempt to do regular software deliveries.
Awesome. Window, how about you?
I'm Snyder. I'm the Chief Security Officer at Square. And prior to Square, I've been in security leadership roles at companies like Intel, Apple, Microsoft, Mozilla, and Fastly. I started off as a software engineer and developed a number of methodologies, including threat modeling, to support application security analysis and mitigation at a time when we didn't have much of an application security space. So I've gotten to see a lot of different kinds of engineering environments and work on security in those environments, and that's what we're talking about today.
Awesome.
I'm Jason Mealins. I work at Tanium. We're an endpoint security platform. I've been doing platform development for about 16 years. We deliver solutions on over a dozen platforms and architectures. And so we aim to help our customers secure their environments and report on everything that they see within them. We do a mostly air-gapped development practice using GitHub Enterprise. And that's about it.
Cool. So before we get too in deep with all of these questions, I just want to level set a little bit, because there's probably some terms that we're going to use quite a bit, and I want to make sure that we're all using the same definition for these. So Rhys, can you tell us a little bit about what shift to the left means, the developer mentality, or noise, what those kind of terms mean to all of us?
Sure, yeah. So shift left is a term that you hear a lot in the industry, so it's a really good one to define what we mean by it. In general, the concept of shift left originates from this idea, or it's not even an idea, it's a concept that when the earlier you catch problems in the software development lifecycle, the cheaper it will be to fix them. So the idea being that problems such as security problems that are caught in, say, the development phase might be 10 times cheaper to address than if they are caught in the testing and QA phase. And depending upon the type of software that you build, it's very hard to put a figure on how much more expensive a security problem is if it actually gets out into the wild. Right? So for shift left, we kind of mean let's try and address things earlier in the software development lifecycle. That's the very theoretical approach to it. Practically, what this means in the security point of view is giving developers the tools they require to perform the responsibilities that we now put on them to secure software from the beginning. So, if we are saying that, security is a shared responsibility and developers take over the role of, or assume much of the role of security, we need more than just words there. So developers need visibility, they need access to policies and things like that. So an example of, like, say, shift left done wrong, just a mild example, which was brought up yesterday at the Birds of a Feather, was where a developer brought essentially a finished product for review, only for everybody to discover. It was built on top of a third-party dependency that was not appropriate for the way it was going to be released. So it had to go all the way back and to be largely rewritten. This is not necessarily the developer's fault if there wasn't a process in place where the second that they attempted to use a dependency that did not match, policies, that they weren't alerted to that. So if we think of how that could have gone more left, first of all, ideally it wouldn't get to like a human review. Ideally that would have been caught in like automated testing. So at the minimum, the minute that it was pushed to GitHub and run on CI/CD, if you have corporate policies for dependencies, then it should have been caught there. Ideally, it could have been caught even earlier, and this is where tools such as IDE plugins come in. So like a developer could literally go to install a dependency and get a real-time alert that this dependency violates a security or a licensing, thing like that. So yeah, so essentially shift left in practice means that if you ask developers to assume the roles of security, you've got to give them the tools and the visibility that they need to do that. You can't just say security is everybody's responsibility.
Awesome. Okay. So now that we've kind of got that cleared up, where do we begin with all of this, right? There's tons of security tools out there. There's best practices. There's experts. There's different roles and functional areas. Do we need to change our models? Do we need to change who we are and what we do? Where window would you say we begin in all of this?
Well, we definitely begin with security requirements, because if you don't define what you need to protect against, then you're operating a little bit blind. And defining the requirements is appropriate even if you're coming into an environment where there's an established product. It's been out there. You've got a legacy of 10 years of code or more, sometimes a lot more. If you don't know what the requirements are, then it's hard to evaluate which risks you can tolerate, which risks need to be mitigated. It's hard to evaluate whether or not this risk is sufficient, this mitigation is sufficient to the risk, and how much of an investment makes sense in these kinds of environments. So I always want to start by identifying what's important, what risks we're concerned with, and what are the requirements to the security requirements for the system. In an organization, trying to figure out where to start, there's a tendency to start in places that are high impact, like looking for vulnerabilities to demonstrate that the work you want to do in making a product, a system, a network more resilient is justified, because look at these vulnerabilities. But if you're in an environment that's already on board with, oh, yeah, we do have to do some security work here because we can recognize that this is the way the landscape looks, that people who are in our space, who are deploying similar apps or operations, do see attackers. So we have to incorporate that into our thinking. Then the investment of demonstration is not nearly as valuable as evaluating the resiliency of the system and starting from the perspective of what are we trying to protect in the system, what mechanisms are in place to make the system more resilient, and are they sufficient to the threats that we see both in our environment and in similar environments, and potentially in environments that are more sophisticated but may have attackers moving from certain kinds of targets to targets that look maybe more like your environment, your app, your deployment.
Awesome. And Jason, would you agree with that? Have you seen similar experience when you're beginning in this?
Yeah, I mean, what Rhys and Window said is very applicable. I mean, you really want security to be all parts of the practice if you want to make it everyone's job. You need not only to arm people with the tools to do good design reviews, you need to have a good security team, you need to invest in outside pen testing resources. There's no single point of success when it comes to security. It's at every point of the development cycle, it's at every moment of progress. You need to stop and reevaluate what we're building, why we're building it, and is it secure?
Do you mind talking a little bit more about that external pen testing group and kind of why you would go external to organization to bring them in?
I think it's you really want to invest in both internal resources. You have these bots that you buy that analyze your source code. You do static analysis. You do thread sanitizer. But when you're looking at your software from the inside over and over again, you tend to get stuck in patterns. So by looking to outside firms to validate your assumptions or uncover new assumptions, you're constantly keeping your security practice fresh. If you stick on one thing, you'll get stuck.
Okay, awesome. And Rhys, what about you? Have you seen any patterns with enterprise customers that are super successful in getting them to start to take off?
Yeah. So this is coming from the experience of seeing multiple customers, and sometimes things seem to work really well, sometimes not so much. One of the things with bringing security tools into the workflow is that you can have this high amount of what we call noise if you're not careful. So tell me a great security scanning tool, and I'll find you 100 people on Twitter boasting that they send all of its emails to trash. If you don't handle the noise right, that's kind of the result that you'll get. And this is especially true if you have like a large number of repositories, or you are, we'll say, shifting left very fast. If you're going from having minimal automated approaches to having, really sophisticated tools. So in terms of what we see companies doing right, that is that they manage the signal to noise ratio. Now, so first part is that, as an example, not all projects are created equal. So you may have like a vulnerability, a security alert, but if that's like an internal timesheet tool or something like that, or if that is a backend that has very strongly typed inputs, then a large majority of the vulnerabilities you might get raised for that are essentially non-applicable. So the first thing that companies doing a good job of is that they have at least two tiers between exterior facing projects and internal ones. Because if you've got a team with limited amount of time and limited patience, if you start alerting them that the building's on fire, and then they look and say, okay, no, that's just not going to happen. So the best ones, the best approaches have a first step automatic triaging between external facing, internal facing. So that can reduce things a great deal. The second approach is a little more subjective, and that is that a large degree of the security threats are still not applicable, even if they are user-facing, because they require the user to have the ability to very specifically craft inputs. So a very good or second step, I should say, in this filtering process or triage is that you try to identify immediately that the description for this vulnerability or this security threat, is it actually possible for the user to craft that type of thing, or is it impossible in our system? Now, even if it's impossible, that doesn't mean you don't want to get rid of it, but it means you don't want to be telling people, stop all the work you're doing, and so on. So basically, that ability to have a multi-stage triage process, semi-automated and semi-manual, where you only alert people to fires when you've gone through a minimal amount of triaging, this is very important, because otherwise you'll struggle to get acceptance of tools, because you're just constantly alerting people to things that they think are wasting their time.
That's awesome. That's a great pattern to get people adjusted to. So let's talk about the breakthrough moment. So obviously you've all come up in your careers and you've worked with different organizations, and they're all in different phases. But if you have a beginning and you start to see your development teams and your organizations start to do things smarter and better, when did you notice that breakthrough moment of okay, we're actually getting it, we're moving there, and how did you keep that momentum alive? Window, you want to take that one?
Sure. In 2002, I had just joined Microsoft, and I had come from a company called AtStake, which was a very early security consulting company, pure play on security consulting. And at Microsoft, there was a lot of pain around malware, and Bill Gates had just released a memo about how we're going to turn the ship and take security seriously, et cetera. But I found that I was beating my head against a wall in terms of trying to get security work in place. Now, to be fair, we didn't have books on security, on application security work back there. There was barely an industry around application or product security. So it's not surprising that there was a little resistance to this, because it's security work that you want to do, especially in an engineering environment, is always in conflict with things like performance or schedule or some delightful feature that you want to ship to your customers, but it's going to undermine the entire security architecture of everything you've built. So it was very hard to make progress until Slammer and Blaster over the same couple of months really inflamed the entire ecosystem. People were feeling a lot of pain. Customers were feeling pain, and that meant Microsoft was feeling pain. And all of a sudden, they were very open to a lot of the work that I was trying to drive there. So pain is very useful, but it's not sufficient, because you don't want your organization to have to go through that pain in the first place, especially if you have contributions that you want to get out into the engineering environment, into the operations and infrastructure that will prevent that pain from happening. So leveraging out someone else's pain is fantastic if you're able to do it. Like, this is what the world used to look like before we did this kind of work, and that's why we do this kind of work, so we don't have to feel this kind of pain. That's fantastic if you can. To see that there are public disclosures of incidents that could have happened to this environment, your application, but won't, because they happen to somebody else, and so we can see that this is a problem that we need to mitigate, make sure that we are resilient against, that we're justified in making an investment in. That's useful as well. But there are lots of organizations that are able to do that kind of work proactively, that are able to justify that kind of investment. And it's generally our responsibility as security folks to try and find the right balance between the business needs and the security risk, and help expose that to the folks who need to make decisions for that product manager, the leadership of the organization, probably you to some degree, if you're in that role to demonstrate and make more visible the kinds of risks that your deployment, application, network, or company are up against. But for the kinds of environments that are just starting to think about what kind of security is required for our needs, not waiting until you feel that pain point is going to mean that you're earlier on in the development phase. You are equipped to do the kind of work that is a design change on a whiteboard before it's a massive code implementation that needs to be reworked or thrown out, hopefully not. And the earlier you're able to make those kinds of changes and raise this kind of awareness, or think about in what ways the application or system needs to be resilient, and to what sort of investment is appropriate for this business, you're going to be able to mitigate that pain for this company. And then the unfortunate end of this is that after you've built something that's pretty strong, pretty resilient, almost certainly you'll get no credit for having done this, because you only see security when it fails. So you just get to know that, like, hey, I think I addressed the things that I care most about, that are most important for this business, this system, and that's going to have to probably be enough for us.
So a breakthrough moment is almost when no one comes knocking on your door for a couple weeks at a time because there are no issues. It's kind of a good insight.
Well, if you don't see any security issues, it might be because you're resilient to it. You're not vulnerable to the attackers that are out there, or it might be because you're not very good at looking for them and your audit mechanisms are insufficient. So yeah, you only know how to look for the things you know how to look for. So instead of trying to address the things you know how to look for, building a foundation of resilience that is functional in its core function is going to help you develop a more realistic sense of what you should have confidence in and what is going to be, let's say, more exposed.
Awesome. Jason, you have any thoughts on that?
Breakthrough moments? I think it's the things that everyone know, having good build pipelines, infrastructure as code. If people are spending a lot of their time trying to recreate their build environments, recreate their dependencies, you're going to keep making different mistakes over and over again. So it's simply just spending the time to make sure packages are repeatable, make sure builds are repeatable, make sure that people can easily test new new pieces of software, new pieces of code, and most importantly, regression testing, right? If you have a zip bomb vulnerability, why isn't that a test? Why isn't that running every time you build? Because it's the 78th time when someone makes a change way over here that something breaks. It's the initial investment in time and infrastructure and build pipelines is invaluable. Like too many times we take shortcuts and we don't spend the time to build our infrastructure properly, and it always pays dividends.
So I want to piggyback off that thought, because we talked about what makes organizations successful. So you kind of led a little bit into what makes them unsuccessful. Rhys, do you have anything to add? Because you kind of talked us through what you've seen that was successful. Can you talk us through what maybe you have seen that is not successful or not working?
Yeah. So I almost did that earlier on the flip side. So we talk about signal to noise ratio. So a classic way to be unsuccessful is to spend time chasing after alerts and vulnerabilities that are not actually applicable. And we can't have a perfect world where we just automatically know for sure. But certainly a classic anti-pattern is chasing after every single alert that is raised. So that then takes it to the next challenge, right? And you say, okay, so how do we, within the organization, how do we kind of prioritize, or how do we decide what to do, right? But this can actually lead to the next problem, which is where if you take an overly simplistic approach to measuring success, and it's very tempting to use, numbers for that, because we all can count and measure. That's a classic mistake. So to give an example, you might bring in security scanning, and you get a number, you get a count. And you can say, okay, so maybe we're going to be modest. We're going to say every month we want to bring that total down, something like that. Or you might say we want to reduce it by 10%, 20%, something like that. So this is kind of like a top-line approach to it. Now, there are a couple of sayings quite similar that I like. One is that you are what you measure. And the other is, show me the incentives and I'll show you the results. Right? So if you take a top-line approach where you say we want to reduce the raw number, then people in companies are rational. And they will do whatever they can do to reduce that number in the quickest amount of time. And that would probably mean they're going to look at ignoring or remediating the lowest priority or quickest to solve first, right? Because you've told them we're rewarding you based upon how many you close. They'll close the ones that are quickest. And that might be almost the opposite end of actually what's most important. You leave the hardest ones, the most dangerous ones, because you've been incentivized to lower a number. On the other hand, though, people might say, okay, I understand that mistake. So what we're going to do is we're going to aim to have zero high-risk vulnerabilities. Like a constant, we get these classifications from the databases, low, medium, high. So we're going to say we want to have a zero high-risk approach, and then we do our best with the rest. And this seems like a good balance, right, to not overload the teams. And the challenge, though, with this is that, again, you're incentivizing them to take a very narrow portal view, because what might be classified as a low or medium threat from a generic point of view might actually be a completely exploitable security problem in a user-facing application. And if you've told your employees, your teams, that you're incentivized or you're measured based upon high risk, then they will naturally ignore ones that are classified as low or medium risk, but actually have a very large impact. So basically, by using oversimplistic KPIs, this is probably the most easy mistake to stumble into, because it seems like a good idea. Measuring is a good idea, but you just have to remember that there does need to be a level of subjectivity, and I think that having staff understand that security is security, and ultimately, we don't want to be exploited. We don't want exploitable problems. Rather than we only focus on the numbers. This is kind of the best way to avoid those types of simplistic mistakes that seem like a good idea when you start out.
Awesome. Okay. So how do we, I'm going to throw this one to you, Window. What kind of culture do we need to establish in an organization, or do we even need a culture to be established so that we follow these successful patterns, but we're not just constantly looking for the easy out, like measuring our successes and looking at statistics? What would you say the kind of a company culture goal could be, if that's such a thing?
So I think the first place to start is with leadership, because that's a smaller number of folks to change. Give folks the space to do the work that they know they need to do. Developers very often know where the security problems are in their software, but may or may not get the time required to address them, and might be incentivized by getting features out, but not for addressing more of the work of maintenance, the work of refinement, the work of resilience. And security is in that set of things. So there's very often large-scale applications that have hundreds of developers working on them, but there's also an understanding that, like, oh, if this thing happened, it would all go sideways. It's not very resilient in this one critical function. Or we've got dead code lying around because the work of going around and taking care of it, assessing it, evaluating if it needs to be refactored, and then the actual work of maybe re-implementing something that hasn't been touched in a while so that it's faster. Well, that's harder than, let's say, we'll just give this more processing in order to support that work. We don't make a lot of space for that kind of work, and finding that balance for the business is really important. That's one thing we can do from a culture perspective, is give folks the space they need to do the work in the first place, and evaluate their success beyond which features they manage to ship, but find ways to reward folks who are making our software more resilient and more robust, more scalable, more maintainable, that kind of work. Additionally, an over-reliance on tools to evaluate whether or not we're doing good work in security is problematic. My phone's been ringing off the hook because someone gave my personal number to a conference at some point, and then it got sold to a bunch of vendors, and now they're like calling me constantly. And it's very frustrating for me for lots of reasons. But number one is that I don't start with a solution and try and figure out how it can benefit my organization. I start with a problem and then evaluate whether I need a solution that is, a third-party commercial tool that I could potentially deploy to fix this problem, or can it be solved by let's say, changes I make in the environment or in the code base, or is there something that we're doing here, like through education, that we could, let's say, do in a more widespread way. A focus on over-reliance on tools and on vendor solutions is problematic, because they very often, especially if they are looking for a signal to evaluate whether or not there's a problem present, is problematic, because they only know how to look for the things that they know how to look for. So let's say one of these tools does something like, let's say it's a static analysis tool for your code base. It goes and looks for the sets of code constructs it knows how to identify that may or may not result in a vulnerability. And to your point about too many signals and trying to evaluate the signal-to-noise ratio, and only devote engineering resources to the noise, to the signal, it's problematic, because that's a lot of work to try and sift through those. But, for example, moving up to a higher level language where memory management is abstracted away from developers really mitigates the risk of corruption and memory corruption issues in a lot of ways. So that's a way to mitigate a lot of different kinds of vulnerabilities at once, and doesn't let's say require the code analysis tool to try and identify whether or not this specific code construct is going to result in a vulnerability. For the most part, those tools are not nearly as effective as, let's say, the eyeballs of a developer who's familiar with both the way the application functions, and also has some security training, security expertise, has spent some time learning how to find vulnerabilities. But if you have vulnerabilities in your system, and you definitely do, trying to find them all is problematic, because, again, you only know how to find the things you know how to find. So instead of finding them all, implementing high-level practices like isolation and compartmentalization, such that there is a vulnerability in this component, I don't know where it is, I'm probably not going to be able to shake them all out with either the tools I have or the skill set that I've got present on my team. So how can I mitigate those specific vulnerabilities in this component? Well, through isolation and compartmentalization, I can make it more difficult for a vulnerability exploited in one of these components to impact other components in the system. I can go through my code base and say, well, here is a bunch of code that maybe doesn't serve a business function anymore. Maybe it's not widely used by our customers. Maybe it was built because we were going to go in a certain direction, and then we decided to go in a different direction. And creating a practice of eliminating code that is, I wouldn't say dead, because if it's reachable, then it's potentially problematic from a security perspective, but maybe not serving a business need anymore. And pulling back on that so that it doesn't, so vulnerabilities in that code base don't impact your customers. These are the only real way that you're able to have a significant degree of confidence that you understand the vulnerability or resilience of your system is through these practices that we've always known how to do, and they are the same in every environment, in like scale up and down the tech stack, whether we're talking about your application server, your operating system, your firmware, your microcode, compartmentalization, isolation, reduction of attack surface, reducing complexity to simplicity as much as possible. Those strategies will make for a more resilient code base, and also a code base or system or deployment that you're better able to evaluate the overall risk for the system, because you can say with confidence, this is, let's say, a narrow communication channel between these two large components. So the attack surface available to this component is reduced by a significant degree in terms of the input that's available to it from the system had to go through a very narrow, well-defined communications channel. And so whatever vulnerabilities are present here are going to be even more difficult to exploit than they would otherwise be. These are going to give you a lot more confidence than some vendor's tool that's going to scan your code base looking for vulnerabilities that code constructs, not even necessarily vulnerabilities, code constructs that might be vulnerabilities, or the equivalent for the deployment end of things might be, the vulnerabilities that are identified publicly in technologies that you deploy in your data center in the cloud that are part of your system. Your ability to patch quickly is critical. But there's always going to be a window of opportunity for an attacker, especially somebody who's going around looking opportunistically for who's deployed this technology. Is it reachable from the internet? What can I throw at it? Can I be successful here? And the window of time it takes to go from a vulnerability being identified to crafting a purpose-built exploit to go after it. It really depends on the team that's doing it, but it's faster than you probably are able to patch. So you're better able to protect your environment if you are able to minimize the attack surface, if you're able to highly compartmentalize, if you're able to create sandboxes or levels of separation that reduce the attack surface within your different components of the system. Those are constructs that you can have more confidence in than your ability to identify whether or not this behavior is suspicious, this code construct might be a vulnerability, or patch quicker than the attacker who's opportunistically waiting to get into your environment.
So there's a lot of work to do.
Yeah.
And obviously culture is a big part of that, right? I think identifying problems before we find solutions is definitely a different way that companies work. They kind of want that easy button, and I think there's a lot of change that's required there. I've got 2 questions left, so Jason, I'm going to have you answer this one pretty quickly. And it's kind of I guess a continuation almost of culture, but is there something that you see companies spending way too much time on? Is it they're overanalyzing tools, they're over-architecting the perfect solution, and they're just not getting their pipeline of their dreams created, or what have you noticed there?
I mean, I think Lindo put it pretty well. I think companies focus on security as a secondary concern. It's something to be solved. You really need to build a culture of security in your development practices. Security needs to be part of what you're doing, not something that is like to be fixed. Things need to be developed and thought about securely. If you're always trying to solve it with a vendor tool, or you're trying to solve it with some sort of thing that gives you a green light, a red light, it's like these tools are good, but it's not it doesn't stop. Security is constant. You have to string it through from the beginning of software design all the way to delivery. If you think that it's going to be solved at one single point, it's not going to be.
Awesome. It's definitely as much culture as it is everything else. Due to the amount of time we've got left, I do want to leave the audience with maybe a bit of advice, a recommendation, whether they are just beginning this journey, whether they've been continuing to do it for years and just can't get over that hump of success. What piece of advice would you give everybody in the audience? One last thing to leave them with. And Rhys, I'm going to start
Okay,
with you.
so one piece of advice. We talked a little bit about the limitations or over-reliance on tools, but at Whitesource we are a tool vendor, so I'm going to double down. I have a favorite quote from The Matrix, and that is, never send a human to do a machine's job. Now, what's important is to understand which jobs are machine jobs, and not to accidentally misclassify. But there are a lot of things that can be done automated and should be done automated. So if it can be a should. So if you have a policy not to have outdated dependencies, then fail a feature request that includes a new dependency that is unmaintained. Automate the updating of dependencies. If you have very specific information about how to fix a vulnerability, then give that patch to the developer to apply, not just kind of a description saying upgrade. So these are what I call like machine jobs, and I think that would be the one thing I'd say is like identify what jobs should be done by machines and automate it. Don't just sort of say to people, hey, make sure you're not using this, or make sure you don't do this, because people will just forget. Automate what you can.
Awesome. Jason, what are your thoughts on that? Or your advice, I guess?
I guess, based on the talk, it's really security isn't something to be solved. It's a process. It needs to be continual. You need to continually practice it. There is no end. So if you think of it as something that will be finished, you're going to have a lot of problems.
Linda?
It would be to evaluate what you're trying to protect and against what first, to establish those security requirements and make sure that your investment in security is appropriate to the threats that you're up against, to the needs of the business, and that your investment should be continuously measured against that as it changes, and focus everything you do in security around whether or not it's satisfying a core need for the business.
Awesome. Okay, well that's about it. We've got like 1 minute left. So if anybody have any last thoughts, parting words, shout outs? No, very quiet bunch. Okay, thank you everybody for your time today. I hope you have some piece of information or something to go with when you go back to your office to start through your journey of balancing agility and security. These guys are going to be here floating around, so if you want to have a little bit more of a deeper dive, they'll be here to have that conversation. So thank you all.
Thank you.